All right, so for today, what we are going to do is figure out how to use the calculator to find lines of best fits and to also make some sort of predictions. So what's going to happen is I'm going to turn the, I guess I'm going to pause, I should say, the recording a couple times because it's kind of time consuming to put things in the calculator. I don't want to waste your time with that. So when I pause, you might want to pause to put data in your calculator. But line of best fit is just going to be the line that most closely follows the trend in the data. Lines of best fit can be positive, negative. There might be no correlation, so it might be a very weak negative or a weak positive. Interpolation is when you use a line or its equation to approximate a value between two known values. And basically what that means is if we were to give you some data regarding the years from 1950 to 1960, let's say we give you information regarding this 10-year period. And then we asked you a question about something that happens in the year 1957. Well, this would be an example of interpolation because the year 1957 falls within that 10-year range we gave you. Extrapolation is use of a line or its equation to approximate a value outside the range of the known values. So what would happen here is, let's say we still talk about the same 10-year time period, but then we asked you to make a prediction based on something that maybe would take place in the year 2010. Well, the fact that 2010 is not within that 10-year period, that's an example of extrapolation. Now, extrapolation could be on either end of the data. So another example of extrapolation maybe would be if we asked you about something in the year 1948. Okay, so interpolation is when we're dealing with information that's within the given data set, and extrapolation is when we're dealing with information that's outside the data value set. You saw this yesterday about entering data. So you should know how to enter data. You should be able to turn your plots on. Diagnostics on, we'll talk about that also. That's something new. Making the scatter plot we did yesterday, linear regression, where we call things y equals mx plus b. The calculator calls it y equals ax plus b. So not a big deal. Their slope is referring to the letter A. Our slope is the letter m. It doesn't make a difference. This R thing that's here happens to be what we call the correlation coefficient, and we talked a little bit about that yesterday. Let's see, we couldn't spell it in class either. So that's the correlation coefficient, and that's just going to be how well your line fits those data points that you graph. So it could be a strong positive correlation or a strong negative correlation. Positive correlation basically just means that your line goes up from left to right. Negative correlation, your line goes down from left to right. And we'll talk about correlations in a second. Okay, so the total amount in millions of dollars spent by the government on mathematics research from the year 1985 to 1995 is shown in the table. We need to put these things into our calculator. The year is going to be considered our L1, and the amount of money is going to be considered the L2. Well, what it's asking you to do, so we all basically have the same information, to center our graph, let 1985 be year 0. So when you type stuff into your list 1, instead of typing in 1985, you're going to type in 0, 1, 2, 3, etc. Okay, so I am now going to pause this. I'm going to get this on the calculator. You should be doing the same thing. Okay, so I've got my information in the calculator, but I do need to show you a couple of things just to make sure that you're good. So let me just arrow over and go up. Okay, so we've typed in all the data into the calculator. You're double checking to make sure that you have the exact same amount of data on both sides, list 1 and list 2, and that the numbers are correct, because if you're off by even one number, it's going to skew your whole graph. So one of the things that it wants to do is to see what type of correlation you have. So you're going to have to take a look at look at your graph. In order to do that, you need to make sure your stat plot is on. So here's where I'm going to show you this once, and then I'm going to pause it for the other ones. Once you go into stat plot, you hit enter. Make sure your plot 1 is turned on, and everything else should be exactly as we need it. So plot 1 is turned on. It's the first type of graph, list 1, list 2, and that type of marking. Okay, once plot 1 is turned on, it's never turned off unless you actually clear your memory again or clear your RAM. So to take a look at this particular graph, it's a statistical plot. So we're going to need to take a look at the window and make sure it fits our data. So we're going to go to Zoom. I'm going to choose Zoom 9. Zoom 9 is Zoom statistics. You can just type in the number 9, arrow down to the number 9, it doesn't matter. And when you hit enter, you see a look at the graph. So this should be a positive looking correlation because the data goes up, or the dots go up from left to right. So we're dealing with a positive correlation. Well, in order to find the line of best fit, remember the calculator is calling this y equals ax plus b, and the correlation coefficient, which happens to be the value of r, we're going to need to turn on our diagnostics and do some other stuff. So I'll do this with you the first time again, and then once it's turned on for good. For diagnostics, what you need to do is go to the catalog, and the catalog is above 0, so second 0. Catalog, it goes in alphabetical order. If you want to jump down to D for diagnostics pretty quickly, if you look above the X -1 button, you see the green letter D. So it's going to be the alpha D, maybe not, alpha D, and there we go. So we need to find diagnostics, and there's two choices for diagnostics, on or off. We want them to be on. So once you hit enter for diagnostics on, you hit enter again to make sure that it's actually done it. Now that you're set, we can find the line of best fit and the correlation coefficient altogether. In order to do that, what you want to do is we need to calculate the line of best fit. So we're dealing with statistics, linear regression. We're going to calculate choice 4, the linear regression line of best fit. You've got to hit enter twice. Enter once says, do you really want the linear regression? You say, absolutely, I do. And there you get it. Y equals ax plus b. They give you the a value, the b value, and r squared value. Not really sure what that is, and we're not going to be using it, so don't even worry about it. And then the r, the correlation coefficient. If we ask you to round this to the nearest tenth, your equation of the line is going to be y equals 15.4x plus 94.7. So that's what you're going to write. You're going to write y equals 15.4x plus 94.7. That is the equation for the line of best fit. When it asks you to write the correlation coefficient, if we go back to the correlation, we know the R factor is 0.99. Usually almost always you're going to round correlation to the nearest hundredth, to the 2 decimal places. So we've got the correlation coefficient to be 0.99. Well, think about this decimal in terms of a percent, and then put that percent and think about it being a test grade. So if 0.99 is 99%, what would you consider a test grade being that was 99%? Excellent, good, fair, or poor? And hopefully the answer is going to be excellent. So we've now answered all the questions. Just to kind of do a quick recap about correlation coefficients, excellent are going to be anything that's in the 90s, and these are decimals, so 0.90s. Good is going to be anything that's in the 80s. Fair is going to be anything in the 70s. And poor is going to be anything below 70 in the 60s, just like a test grade. Excellent test grades, good test grades, fair or poor. Alrighty. I'm going to pause again, get this next graph into the calculator. It's talking about the 1999 win-loss statistics for the American League East Baseball teams on a particular date. And the wins are going to go into list 1, and the losses are going to go into list 2. So please get this into your calculator. Okay, so we've got the data in the calculator. We want to take a look at what the graph is. And when you take a look at the graph, you do another zoom stat. Every time you put a new data, you have to do a new window, a new zoom 9. So here's what the graph looks like. Okay, this should be a negative correlation, all right, because the points are going down. If you want to find the equation for the best fit line, we do what we did before. We go to Stat, and we arrow over to Calc, and we arrow down to Choice 4. We hit Enter, not just once, but twice to get the new thing up. So let's take a look at, we've got some information here. So if you notice, you've got your well, first of all, your slope is negative, but that should make sense because we had a negative correlation. And the correlation coefficient is also negative. So we need to be able to write this to the nearest, we're going to do this to the nearest hundredth this time. we're not giving you, which we should be, telling you how far to round this to, but I'm telling you now it's the nearest hundredth. So correlation we know is going to be negative. To the nearest hundredth, we get y equals negative 1.01x plus 88.14, and the correlation coefficient is negative 0.98. Disregard the negative, okay? This we're turning, if this turns into a percent, it's a 98%, and this will be, not that it's asking you for it though, an excellent line of best fit. Let's just make sure we've got that correct, okay? So y equals negative 1.01x plus 88.14, and with the negative 0.98 nearest hundredth, which is excellent. All right, so then we're going to go to the next one. I'm going to pause it again, get the information in the calculator, and then I'll... Alrighty, so the data is back in. So what we want to do is write a linear regression equation that that relates the price of the cottage to its distance from the beach. So I'm going to go back to, let's take a look at the graph, by the way. So zoom 9, another negative correlation. Let's take a look at the line of best fit, stat calc 4, enter. Okay, and let's take a look at this equation. We're going to round this. Let's round this to the nearest hundredth as well. So the nearest hundredth is going to be y equals negative 34,739.71x plus 313,309.10. Okay, so let's get this thing written down. So we've got y equals negative 34739.71x plus 313,309, and I forget the rest of it. Hold on. 0.10. 0.10. Okay, so there's the equation. It wants you to use this equation to predict the price of a cottage to the nearest dollar that's located 3 blocks from the beach. So what you're going to do, at least for now, is you're just going to type in the number 3 on the calculator for where the x is. So it's going to kind of look like this. And I think tomorrow, the next day, we're going to show you how to dump everything into the y so you get more of an accurate answer than an approximate answer of what we're doing right now, 313,309.10. Okay, so I believe well, I should probably plug it in because I got a different answer on here. So we're going to now do, let's see, so negative, let me go back to, as I'm running back to the computer, it's just easier to type it in. All right, so now I've got this. I've got, so negative 34739.71. We're going to multiply that by, so multiplied by 3 blocks, and then we're going to add to that 313,309.10. Okay. And so then approximately how much would this thing cost to the nearest dollar? And to the nearest dollar, we're going to cost $209,000. $209,090. So 209,090. 209,090. Okay. I got one more to go. So I'm going to pause it again. This time you're putting into the calculator the availability of leaded gasoline in New York State is decreasing, as shown in the accompanying table. And then we're going to deal with the years. So you can either, let's actually type in the years, 1984, 1998. Yep, there we go. I'm just taking a look and see what's on here. All right, so I'll be right back. Okay, so all the information is in. Determine the linear relationship for X years versus Y gallons based on the data given. The data should be entered using the year and the gallons available in thousands. So we've done that already. So we're now going to go back to our stat calc 4, enter, and here's what we get. Y equals negative 6.2x plus 12,451.2. Okay, and then we need to figure out some other stuff. So let me just get this written down. Okay, so Y equals negative 6.2x plus 12,451.2. Just gonna make sure I got that right. And I do. Okay. So then if this relationship continues, determine the number of gallons of leaded gasoline available in New York State in the year 2005. So then what we would do is we would have to basically type in what we have up here. So Y equals negative 6.2. The year is 2005 plus 12,451.2. I'll do that math in a second. I guess we should do that now. Okay, so then we got this one right here. So negative 6.2 times 2005 plus 12,451.2. Okay, so then it looks as though what's going to happen there is if this relationship continues, then the number of gallons of leaded gasoline available will be about 20 gallons of gas. It doesn't tell you whether you should round it or not. I'm just going to leave everything as the decimal, so we'll say 20.2 gallons. And then if this relationship still continues, during what year will leaded gasoline first become unavailable to the state? Well, it's unavailable if we don't have any gas. And if you don't have any gas, then the gallons available is going to be 0. So 0 is going to be negative 6.2x plus 12451.2. To solve this thing for x, you're going to subtract 12451.2 from both sides, and you'll get negative 12451.2 equals negative 6.2x. And you'll divide both sides by negative 6.2. Let's see what happens here. Negative 12451.2 divided by negative 6.2. And the year is going to be, now it's 2008.2, but that's basically going to be the year 2008. So we've got the year is going to be 2008. Okay, so right now with all of these things, when you get them on your calculator, use your rounded linear regression equations to find your answers, and then we will show you how to actually put the entire regression equation into your calculator so you get a more accurate answer. Okay, so hopefully this is going to work for you. Good luck on your homework.